This assignment teaches you a little more about reading in data with SAS and also how to compute standardized mortality rates, both overall and by strata. So first we're going to start here. This first line is just a comment. So if you do a backslash, asterisk, anything up until you hit an asterisk and a backslash like this is going to be interpreted just as a comma. So this is our proc STD rate, again, which is standardized, not sexually transmitted diseases, just so you know. And we're in part A, comparing Florida to the US. So data, I'm creating a data set here, Florida underscore all, event underscore F equals 538, semicolon. So I can just create a variable and give it a value here if I want to. Total underscore F equals, what is this, 15,658,227, semicolon. So this data set's only going to have two values, the value for the events, the number of people who got skin cancer, and the value for the total number of people in the state. Now I create another data set, data, US underscore all, and similarly I give it two values, event underscore U equals 7,420, which is the number of people who got skin cancer in the entire country, and total underscore U is 281,422,206, semicolon. So that's the total number of people. So you can enter data like this, but in this case it's only useful because we only have one record per data set here. Overall, that wouldn't be a great way to do it. Proc STD rate, data equals, this is the study data set, so Florida underscore all. Ref data, that's our reference data set, equals US underscore all. So I'm going to compare my data from Florida to all of the US. Method equals indirect. Stat equals rate, so I don't want a risk value, I want a rate. And in parentheses, multiple equals 100,000. So it's going to give me the rate per 100,000, which is actually the default. Plots equals all will give me a bunch of plots, semicolon. So this finally ends the proc STD rate statement. Population, event equals, the name for the event in my population is event F from up here. Total equals, the total number of people is in the total F variable. Reference, my reference population was the US, and the event variable there equals event U, and my total population for the US equals total U. Run. So let's do this and see what we get. I can highlight it, click my little running guide. Normally it doesn't take that long, but here we go. So by rate, I scroll down here. Here is the reference value. Here is the value for Florida. So you can see they're quite far apart. This is by strata. I only have one strata. My observed events were 538, and my expected events were 412. So my standardized mortality rate is 1.3031, and you can see I have a z-value of 5.4 and a probability of less than 0.001. So that's interesting. Let's go back over here and do it by strata, because we all know that there's more old people in Florida, right? So maybe more old people get skin cancer. Who knows? So we'll try this. I just a couple more comma statements. Part B, comparing Florida to the US by strata. So I create a new data set, data, Florida, semicolon, input, age, and here shows a different way of reading in your data. So this is character data, because even though age is a number, you can see it's not just numbers here, it's 0 to 4, 5 to 14, and so on. So it's going to be in columns 1 through 5. When you put in your data, make sure it's in columns 1 through 5, just like this. Event comes next after age, and this is per year. And this is another format for reading a data, comma, 11, period. So the period here, there could have been decimal places, but there's no decimal places in the number of people. You don't have 953,785.7 people. So this just says that these are numeric data with a comma in them and no decimals. So you can see that's exactly how it looks. And they're going to be up to 11 spaces. There's up to 11 spaces here, counting the commas, mind you. So I have specified my data. I'm going to read in data lines, semicolon, alert SAS that what follows is data. So here's all of my data for the state of Florida, a semicolon to denote the end of the data entry. And now I'm up to my next data set. Same thing, data for the US, semicolon, input, exact same input statement, except here it's column 12, because of course we might have a bigger number because there's more people in the country than there are just in Florida. There's my data lines again. There's my data for each age group for the country. Now I'm going to do the proc STD rate again, except this time I'm going to have another statement where it says strata. I'm going to stratify by age. There's a slash here to denote that there are some options coming up, and the stats I want as SMR, the standardized mortality rate. Other than that, it's the same as before. Our method equals indirect. Our stat equals rate with multiples of 1,000. We want out 100,000. We want out the plots. There's the population event equals, very uncreatively called event in both data sets. And the total is per year in both data sets. So now let's try running this and see what we get. Now here you see we have more than one stratum, so there's a bunch of strata distribution plots. And at each age group, you can see here's my reference group, the US as a whole. And here is my study group, the state of Florida. Up here, I get the crude rate for my study population, which is Florida. And over here is the 95% confidence limits. And over here is the crude rate for my reference population, which is the country as a whole. And where, if you remember back to the original plot we looked at, there was a huge discrepancy between the reference population and the study population. You can see that right along all of these graphs, the reference group falls right within the confidence limits for the study group. So in other words, it seems like the difference in Florida's skin cancer rates was more a factor of differences in age, and just to show that, hey, maybe that's true. Down here we can see that our new z-value, when we stratified by age, is 0.4, and our probability is 0.6893. So what does that tell you? Well, I guess that's the question that you're supposed to be answering.